Okay, so for question 3, this portion of the exam will be matching, right? So there's going to be some expressions like this. I think I'm going to ask you to match the expressions you see with their simplified versions or things that are like these. So let's go ahead and just go ahead and simplify these, and then you'll do some matching stuff when you're taking the test. So for this first problem, we have 3x getting squared. So it's important we understand that there are parentheses around this. So this is telling me that the entire 3x is getting squared. In other words, this is the same thing as a 3x times another set of these factors 3x. Well, when I multiply a factor of 3 times a factor of 3, I do get 9. And when I multiply an x times an x, I do get x squared. So this simplifies to 9x to the second power. In part B, you'll notice that the 3x is not in parentheses. The only thing that's being raised to the negative third power is the x. Those three factors of x I can move to the denominator. My justification for that is anytime I have an expression, I can multiply by the number 1. And I choose the form of the number 1, x to the third over x to the third. I selected that because when I multiply x to the negative third times x to the positive third, that equals exactly x to the 0 power, which is equal to 1. Bottom line of the story here is that the things I've highlighted in green, that is equal to the number 1. So the numerator becomes 3 times 1. 3 times 1 is just 3. And you can see in my denominator now I have x to the third power. So what I said initially was when you have this x to the negative third power, I can move 3 factors of x into the denominator, and that would be equivalent. And this is my justification for why. Let's go on to C. Okay. So for C, there is a 6 divided by 3. 6 divided by 3 is the number 2. So in my answer, I know I'm going to have a number 2 in the numerator and a 1 in the denominator. The other thing I'll do is I will move these 2 factors of x up into the numerator so that it'll make this become x to the 7th. Again, it's not magic, right? I'm just multiplying by the number 1. Multiplication by 1, I guess, is a magic thing. In this denominator, when I multiply x to the negative second times x to the second, that product is equal to the number 1. So I can say there's another factor of 1 in the denominator, but 1 times 1 is still 1. In the numerator, I do end up with x to the 5th times x to the 2nd, which is x to the 7th power. So my final answer would be 2 times x raised to the 7th power, because if I divide by 1 and then divide by 1 again, it doesn't change anything. A, B, C, D. So for D, I have x to the 4th times x to the negative 2nd. I could move those to the denominator, but I don't need to. I'm just going to combine them. So x to the 4th and times x to the negative 2nd is just going to be x to the 2nd power. And there's lots of reasons why we could justify that. But remember just the definition of what an exponent is, right? If I say x to the 4th, that's an x times an x times an x times an x. And this x to the negative 2nd is an x times an x in the denominator. It was in the numerator. It had to get kicked to the denominator. And if I look at this, these form a giant 1, so I'm left with x squared, right? Or I can get proficient with shortcuts and, hey, 4 and negative 2 added together are positive 2. So this is x to the 2nd. On E, I've got 6 divided by, or 9 rather, oops, careful. I've got 9 divided by 3, which is 3. So there's a 3 in the numerator. I still have the x to the 6th in the numerator, and there is a factor of x in the denominator. And to be precise, if I see x with no exponent, I know it's x to the 1st power. So if I have 6 factors of x in the numerator and 1 factor of x in the denominator, that leaves me with 5 factors of x in the numerator. So this is 3x to the 5th power. And then for the final one, f, I have this expression. And I can simplify this expression, right? This expression would be x to the negative 2nd, which would be 1 over x squared. That's true. That's true. But the thing that I notice here near the end is that they're all raised to the 0 power. So it really doesn't matter what is in here, right? This is simply equal to 1. And I say that and I realize, well, there's actually an important, I guess, exception to that. So if I was to look at my graphing calculator, oh, where are you at? There you are. If I was to look at that and say, I pretty much anything, so I'll do open parentheses, negative 33695. If I raise that to the 0 power, it's going to give me the number 1. If I go 25.231, it doesn't matter. Raised to the 0 power, it's going to give me the number 1. The one noticeable exception is if I take 0 and I raise that to the 0 power, right, I get an error. There's a domain error there. So as long as x isn't 0, anything as long as it's not 0 raised to the 0 power equals the number 1.